So welcome back to Master Academy of Mathematics. This is the next continuation topic of your multiple integrals. So it is volume by triple integral. You are calculating a volume corresponding to a given equation by applying triple integral. The same type of topic already we have completed, volume by double integral. So you can calculate volume either by double integral or by triple integral. So whenever a problem is given, better you look on to that. So depending on your problem, now I am calculating the volume by triple integral. I just give you the procedure, only little bit of steps. The first step is an equation is given, and from that equation you are just calculating the limits of variables x, y, z. You need to calculate three limits of the variables, three variable limits. The next is you are calculating the volume corresponding to the given equation by the triple integral dz dy dx. My best suggestion is z can be represented in terms of variables, y is also represented in terms of variables, only x is represented in terms of real numbers. So based on that you can directly find out the volume corresponding to the given equation. Now let us have a problem. Find the volume of x by a plus y by b plus z by c equal to 1 by the triple integral. So in the problem itself they are mentioning you are applying the triple integral to calculate the volume. If they are not mentioning, you can use your double integral also. So in both the cases you can get an answer. So depending on your problem statement you are using the formula. Now at present I am using the triple integral. In order to do that I am just taking the given equation. So what is the given equation? It is x by a plus y by b plus z by c equal to 1. From this you calculate only z. Z equal to, I can write c into 1 minus x by a minus y by b. Okay, therefore the z limits are 0 to c into 1 minus x by a minus y by b. So z limits are over. Similarly, in order to get the y limits, you substitute z equal to 0. If I write z equal to 0 in the previous equation, you will get directly 1 minus x by a minus y by b equal to 0. From this, you will get y equal to, what will be the y value? B into 1 minus x by a. So therefore, your y limits are 0 to b into 1 minus x by a. Similarly, in order to get the x limits, you just suppose y equal to 0 in the previous equation. So that you are getting 1 minus x by a, that is equal to 0. From this only x equal to a. So therefore your x limits are 0 to a. So this is the way how you are calculating the limits by using the given equation. Therefore you are calculating the volume. The formula for volume is, it is triple integral you are writing, and just you write down it is dz, dy, and here it is dx. This is about x integral, y integral and z integral. Write down your x limits 0 to a and y limits are 0 to b into 1 minus x by a, and z limits 0 to c into 1 minus x by a minus y by b. So nothing is there, directly dz, dy and dx. Okay, so first two integrals you are keeping as it is, 0 to a, here it is 0 to b into 1 minus x by a. Now integral of 1, it is nothing but z. So write it is z, the limits are 0 to c into 1 minus x by a minus y by b. Still we have here it is dy and dx. So it is x equal to 0 to a, y equal to 0 to b into 1 minus x by a, substituting your upper limit c into 1 minus x by a minus y by b, and lower limit is equal to 0, so that dy and dx. Now what about the next integration with respect to y? X equal to 0 to a. I am taking this c, anyhow it is a constant, you can take it outside. Integral of this. So I am taking 1 minus x by a is only one term. So integral of, there is no y term, into y minus 1 by b you can write as it is. What about the y integration? It is y square by 2, and you are substituting that y limits. It is 0 to b into 1 minus x by a. So this is equal to c x integral 0 to a. Now I am substituting the values here. 1 minus x by a as it is, and in the place of y you are writing b into 1 minus x by a. Similarly, minus 1 by b into y square value, it is b square into 1 minus x by a whole square divided by 2, and lower limit is equal to 0, and here we have still dx. This is also dx. Okay, first you do the simplification. It is c into integral x equal to 0 to a. So b, it is nothing but that 1 minus x by a, same value is there. You can write whole square, and minus 1b is cancelled. So you will have b by 2. It is 1 minus x by a. It is also whole square. This is of dx. Now you need to find out the integration with respect to x variable. Now this is equal to c as it is, integral x equal to 0 to a. So that b you can take totally common. So b I am taking common, and 1 minus x by a, it is whole square, it is also common. So what will be the remaining term now? This is 1 minus 1 by 2. That becomes only 1 by 2 of dx. So totally bc divided by 2, integration of this. So it is nothing but 1 minus x by a. This is totally whole cube divided by 3 into minus 1 by a. That is the easiest formula to get your complete integration. And what about the limits now? That limits are x equal to 0 to a. So total it is bc by 2. Now I am substituting your upper limit. In the place of x you substitute a. 1 minus a by a. So 1 minus 1 is totally 0. Upper limit is 0. Minus, when I write x equal to 0, you will get 1 divided by minus 3 by a. Okay. Now this is equal to bc by 2. It is minus into minus is plus. So totally you will having here it is into a by 3. Or I can write abc divided by 6. That is your final volume of a given equation. Now let us have certain exercise problems to find out the volume by triple integral. Find the volume of x square by a square plus y square by b square plus z square by c square equal to 1. Same procedure. Find out the x, y, z limits, and directly you will get the answer is 4 pi by 3 into ABC. Similarly, I am giving you one more different problem. Find the volume of two equations are given. X square plus y square equal to a square and x square plus z square equal to a square. So in that particular equations, the thing is, from the second equation you find out the z limits. What about the z limits now? Z square can be taken as a square minus x square. Only z is under root of a square minus x square. So z limits are 0 to under root of a square minus x square. Similarly, from the first equation you can find out the y limits, which is nothing but 0 to under root of a square minus x square. How to get x limits? Either you can substitute z equal to 0 or y equal to 0. From the equations you will get x limits are 0 to a. So by that you can get your answer 2 by 3 into a cube. So these are the few fundamental problems of volume by triple integral. So with this, volume by triple integral is closed. In the next video session we will enter into center of mass and gravity. With that we can close your complete multiple integrals.